Okay, finally we're ready to graph these guys. Number one, let's graph. R of x is x minus 5 over x squared minus x minus 12. We did all the work. We said, oh, vertical asymptotes, y-intercept, and we said that the horizontal asymptote is y equals to 0. So here is, draw yourself an xy and label what you can. This is what we can label. Y equals to 0 is a horizontal asymptote. So if I had a pencil instead of a whiteboard, I would just heavy dash that on there. Y is 0 is a horizontal asymptote. Label your vertical asymptotes. We have one over at x is equal to negative 1, negative 2, negative 3 right here. X is negative 3. We have one at x is 4. 1, 2, 3, 4. This is where we have another. X is equal to 4. Okay. And then we have a y-intercept at 0, 5, 12. So it's not even up here. If this is 1, it's not even up here. It's about right here. This is where the y-intercept. I didn't talk about finding the x-intercepts, but if they're convenient to find, go ahead and find them. This one's convenient to find. The x-intercept come from where r of x is equal to 0. When you have a fraction, it will never equal 0 unless the numerator equals 0. So when the numerator, x minus 5, equals to 0, when x is 5, then the whole function will be 0. So this one was pretty easy to find. So that gives me another point right here at 5. It's going to be crossing. Okay, so that's all the information I have right there. Then what I would do is I would plot some interesting points. I'm going to use my graphing calculator because it's fast and convenient. If I wasn't allowed to use my graphing calculator, then what I would do is just use my brain, and I would just plug in all these x values. What important points or interesting points are anything to the left or right of a vertical asymptote or an intercept. So I want something like maybe negative 4 and negative 5 on the left side of negative 3. Maybe negative 2, negative 1, 1 and 2, negative 2, negative 1, 1 and 2. Maybe 5, 6, 5 and 6. On that side, that would help me know what was going on with this guy. And so if I wasn't allowed to use a graphing calculator, I would put negative 4 into this function and calculate it. Since I am allowed to do that, I'm just going to use my graphing calculator and go to my y equals screen. And I'm going to enter my rational function. And I'm going to put in x minus 5 in parentheses, divided by parentheses, x squared minus x minus 12. And you can just hit graph, and you can see a picture of it. You can also go to second table and get some values out. So I want these values. Now, since these are whole numbers, so I'm just going to go down and see what they would be. It says that at negative 4, I would get negative 1.125. Let me see what that is. Negative 1.125, and these do not have to be negative 1.125. At negative 5, I get negative 0.56. At negative 3, I get error. That makes me feel good because I knew that would be an error because it's undefined there. At negative 2, I get 1.17. At negative 1, I get 0.6. At 1, I get 0.3. At 2, I get, okay, so this was 0.33. At 2, I get 0.3, so it's getting a little smaller. At 5, I get 0. Oh, I already knew 5. That was silly of me. Let's see, 6. I get 0.056, 0.056. I think that's enough for me to be able to sketch this guy, understanding how a graph works with its asymptotes. Negative 4. This is not going to be that accurate and doesn't have to be to get a sketch. This is negative 4. What this tells me is that at negative 4, I'm at negative 1. This is negative 1. I'm at negative 1.1 something, about here. At negative 5, I'm not that far down. I'm only at negative 0.56, so I'm going up. Those 2 points with this asymptote are enough to let me know what this function will look like. It will look like, it will hug the horizontal asymptote, y equals 0, and it will hug this vertical asymptote, x is -3. In the middle, at -2, I'm up here at 1.17, maybe there. At -1, I'm down at 0.6, maybe there. At 1, I'm at 0.3, maybe here. And at 2, I'm at 0.3, maybe here. Oh, I want to put in 3 and see what happens. At 3, I'm back up at 0.3. I'm back up at 0.3. So what this tells me, it didn't go negative. That tells me that it's going to come in here, and then it's going to start to, it's going to get that U shape in there. Over there at 5, it's 0. And at 6, it's 0.05. With this asymptote here, I know it's going to do this and kind of go back. This is going to go back down and kind of hug the vertical asymptote there. Now you can always check with your graphing calculator to make sure you didn't make an error. So let me see what this guy looks like. It's graphing right now for me. This is what my graph looks like on the screen, if you can see that. And so it basically looks the same. And if I'm in doubt, I can check with my calculator. Okay, let's go ahead and do number 2. Hopefully it won't take as long to do number 2. Let's erase all this stuff. Number 2, we said that it had a horizontal asymptote at y equals to 1. It had 2 vertical asymptotes at x is 2. So let's see what this guy will look like. Right here's vertical asymptote, x is -2, -1, -2. X is -2. X is +2. Y equals to 1. Y equals to 1. Horizontal asymptote, vertical asymptote, vertical asymptote. No holes. Okay. So, for this one, we're just going, what are some, do we find a y-intercept at 0, 0, right here? Turns out the x-intercept is also going to be at 0, 0. It's the same point. So we can put some points into our calculator, and just to save time, I'm not going to list them, but important points would be anything to the left or the right of asymptotes or intercepts. I'm just going to put this in my calculator and say parentheses x squared minus x divided by parentheses x squared minus 4. And then I'm going to graph this guy and see that it looks like, this looks like this. If I ask you for a test just to pick some interesting points, you would just have to show me, you could use your calculator to find out what those points were. You could use your calculator to graph this, but I might have you make a list of what you thought were interesting points or important points. And so these are the ones that I would expect you to put in. Maybe like -3, -4 to the left of this asymptote. Maybe -1, maybe -0.5, 0.5, 1 to the right of that intercept, and then maybe 3 and 4. Something like that. Okay, that's that one. Let's look at 3 real quick, and then we'll be done. 3 goes like this. We know it has no holes. We know it has 1 vertical asymptote, and we know that it has an oblique asymptote. Okay, how do you find oblique asymptotes? You find them by dividing the denominator into the numerator. You find them by dividing x plus 1 into x squared plus 0x minus 5. You could use long division or you can use synthetic division. It doesn't matter. X goes into x squared. X times x is x squared. X times 1 is x. We're going to be subtracting. X squared minus x squared is 0. 0 plus -x is -x minus 5. X times what is -x minus 1. -1 times x, -x. -1 times 1, -1. We're going to change signs and add. This is 0. This is -4. So we find that R3 of x plus 1 goes into that, x minus 1 times plus -4 over x plus 1. Because horizontal asymptotes and slant asymptotes are defined in terms of very, very large numbers of x, when this x in this denominator is really, really, really big, like a million. A million plus one. When you take -4 divided by a million plus one, or something bigger like infinity, then this basically goes to 0. And for that reason, when you are talking about slant or oblique asymptotes, those mean the same thing. You can throw away the remainder. So right here, the slant or oblique asymptote is y equals to x minus 1. That's what that is. That's what we did there. That's the slant. So let's graph this guy real quick. All right. We know it has a vertical asymptote at x is -1, right here. X is -1. We know it has a slant asymptote at this line. I'm going to graph this line. Down here is -1. The slope is 1/1. I'm going to go up 1, right 1. And so it's going to look like this. This is my slant asymptote. Y is equal to x minus 1. Slant. Vertical. We know that it had a y-intercept. Did we find that at 0, -5? So 0, -2, -3, -4, -5. Okay. So this point is not a point on the graph. That's just something I use to graph the asymptote. All right, what I would do is pick some important points. I would expect you to at least list them and find the, you could use your calculator to find the values, but listing them is good. R3 of x, we would say something to the left. So this is -1, right? So I'd go maybe -2, -3. Maybe, we know what it is at 0. Maybe -1/2 would be important, somewhere in here. Maybe 1/2 would be interesting. And then something over here, maybe 2 and 3. That would probably be enough. I'm going to put this in and graph it. I'm going to use my graphing calculator. And again, if you were not allowed to use your graphing calculator, you would simply plug these values in and see what they were and sketch your graph. So I'm going to say y is equal to x squared minus 5, parentheses, x squared minus 5 divided by parentheses x plus 1, and I'm going to graph it, and it's doing some interesting things. This is what it looks like. I don't know if you can see my screen, but that's what it looks like. Okay, but I'm going to graph that in here. It looks like when you see it bending like that, it's going between this guy, it's kind of coming in close, and then it's going to hug this asymptote, and then it's over here. It actually hugs this and crosses, and then it kind of bends up like that. That's what this graph is going to look like with that little slant asymptote in there.